Good morning. Today we are going to talk about Hugging Face ecosystem. So what is Hugging Face? The logo of Hugging Face looks like this one. Is an emoji. And it is a company. Was founded in 2016 by a French guy. And initially it was developed a chatbot app and for teens. So that makes sense. It choosing the emoji. The emoji, the Hugging Face emoji, as its brand, its name, because it's target the teens. So the name is come after the Unicode emoji, which is the Hugging Face. But later on, it pivoted towards to provide open source tools and solutions for natural language process. So it began with its open source, it's the chat language model behind it. And I think this pivot choice make the Hugging Face to be very, very popular and become one of the most important ecosystem in data science and machine learning and AI, especially focusing on the NLP. But I think it will build around this, the language applications, and will extend to other fields as well. Like saying that the diffuser library is for text to image generation or image to image generation. It is also getting popular as well, and as well as other like the serverless inference services, model handling, and also other libraries acquired by the Hugging Face, like the Gradio, which is a UI builder for the data science machine learning project, and also the team TIMM is also acquired by the Hugging Face. We will talk about them later. So as we can see before, the primary factor about how the project or how something is going to be successful is about the ecosystem. This is same thing happens to the like NumPy, PyTorch, or maybe like image scikit-learn things, and also like pandas, things about pandas and polars, or maybe even with the Rust, everything, or Python, Python for sure, everything to determine a project or software is going to be successful. The primary factor you should consider is the ecosystem, not the feature, not how advanced the feature or the functionality of that product or software. Of course, these things like features or functionality are important, but and they may contribute to have a healthy and successful ecosystem. But I think the most direct and primary and important reason that to make a software successful is the ecosystem. Because if the ecosystem is getting stronger and bigger enough, all other like drawbacks or bottlenecks is going to be solved, because there are a lot of developer and user base. I will see it later. So because we are focusing on the ecosystem, at the last part of this lecture, we're going to talk about the competitors and other alternatives to the Hugging Face services. Like Google provide a lot of different things that can be somewhat compare or compete or consider as an alternative to the Hugging Face services. It provide a model garden, and also it provide the Colab and the Google Gemma and the Gemini Studio, Google AI Studio, which we'll talk about at the last part of this lecture. But before that, let's talk more about the history and why the Hugging Face is going to be success. On 2021, so that is like 3 years ago, the company launched a big science research workshop and a collaboration with several other research groups and released an open large language model. So as a result, in 2022, the announcement of Bloom, they announced Bloom that is a language, which is a big language model. It has 176 billion parameters, and because Bloom is one of a milestone of open source language models, you may remember that back then there are Taiwanese localization of the large language model, which was originally based on Bloom, but recently all these efforts are based on llama-based models. Also in December 2022, the company acquired Gradio. Although Gradio is something kind of similar to the Streamlit or the Partly Dash that I mentioned before in when I introduced the Partly or maybe other software, I kind of forget, but I use Partly Dash a lot, and I think Partly Dash or maybe even NYCU is probably more suitable for developer to develop quick prototype, but because Hugging Face has a huge ecosystem, and so is Gradio. So I think Gradio still have a very bright future and is going to catch up in a lot of different aspects, and perhaps it will dominate the market. Even though I think Partly and Partly Dash got a quite decent ecosystem around it, which I probably mentioned before, and NYCU is not so. The NYCU has a kind of small ecosystem, which probably can be considered as a weakness of the NYCU. I really like NYCU, but the ecosystem is just too small compared to these two big guys. And the Hugging Face is not only big, it is huge. So if I want to bet on one of the framework, even though Partly Dash is more feature complete and you have more freedom and it can build more modern style application, I probably would still bet on Gradio because of the popularity and the ease of use. Okay, in August 2023, it raised 235 million in Series D funding and get a 4.5 billion valuation, which is really big. And it is support, you can see, by many big companies, because you can see the funding was led by Salesforce, and it has some participations came from Google, Amazon, Nvidia, AMD, Intel, IBM, and Qualcomm. And in 2024, in this year, in June, the company also works with Meta and Scaleway to launch new AI accelerator program in European startups. So you can see all the big names and can work with them. So that's how if you have ever used the Hugging Face before, or maybe just a little bit to try some services provided by some demo or download model from it, you probably has a test of how large and how popular the Hugging Face is. But even if you don't, from these like variations and working with other companies, big companies, you probably can imagine it is one of the big things and probably will going to remain for at least for several years. Okay, here is a list of some of the Hugging Face tools. Because like you see, like Hugging Face has been pivoted before. And originally, after it is pivot, it is not clearly what the Hugging Face is aiming for. Because other than the Hugging Face model and later on the Hugging Face space, it probably seems nothing like, okay, it has transformers, it has diffusers, but the transformers and diffusers are just popular open source project. You can consider them as other open source project that is getting really popular. But other than that, it is kind of like just a hub, and it has served the models or maybe some code and demos, and that's it. It's kind of like GitHub, but GitHub is a huger thing. However, I think in recent years it is getting more clear and clear. It is going to become a center repo of the AI development, kind of like the GitHub for AI, but not only for code, not only for like model hosting. It is for everything. So it is, you can consider it is a new GitHub for AI. So it also hosting like blog post, like paper, discussion, and everything. Some of the notable services I have listed right here. One is Transformers, which is a leading large language model training and deploy an inference library. Although there are some alternatives like llama.cpp or maybe like sloth or other, but I think Transformers is still getting it's one of the huge things, if not the hugest one. And also the primary functionality on the website is the hub. It including the model repository, code repository, and it has spaces that can run the demo. We will talk about some of the alternatives, but one of the interesting things about the hub space is it provides a hardware called Zero GPU. It provides some traditional hardware like just give you a CPU instance like a virtual machine, like a GPU virtual machine, or maybe like a TPU virtual machine. But it also provides a free service that called the Zero GPU instance. That is actually free, but you can use serve your model on GPU with some simple modification. And also another library is important, which is important as diffusers and Gradio. Gradio is also important, which we will talk more about the transformers and the Gradio. Not so much about diffusers in these lectures. So first, we are focusing on the transformers library. This is the first key point in first topic in this lecture. So what is a transformers? Just in case you haven't used it before, it is a Python package that contains open source implementations of transformer models for text, image, and audio tasks. The backend includes PyTorch, TensorFlow, and JAX, but primarily for PyTorch, which we will see later. But still, because the support of TensorFlow and JAX for some model, especially for Google models, it would probably more convenient to use the TensorFlow or JAX backend. Originally, it is called the PyTorch pre-trained BERT. Because it is originally served with BERT models, fine-tuned BERT models, but then it remains to PyTorch transformers, and finally it's just called the transformers, probably because it supports with TensorFlow and JAX. It used to be a Python-only library, but it forks to a JavaScript version, which called the transformer.js, so that you can serve transformer models on like a web page. Here are some of the model. The first few is sorted by the name in dictionary order. Just a few. It has a lot of models supported, like here. Let me scroll down to let you see how long the list is. Not finished yet. Still not finished, but we are getting close. Okay, so it has a lot of transformer-based model, including some object detection models as well. Not only just for text or audio, it has a lot of like image models, video models, like object detection models. But you can see that the first column of supportness is about the PyTorch support, and the second is TensorFlow support, and the last one is the Flex support, which Flex is a JAX library. It's a library built on JAX, which can be considered as a high-level API on JAX, sort of like the relation between Keras and the TensorFlow, but not exactly. But you can see that a lot of model doesn't. This depends on the architecture of the model. Like for Llama, there's just a Llama architecture. It supports many different versions of Llama. But you can see that all of the models support PyTorch backend. Everyone support PyTorch. Probably like 20% or 15% to support the TensorFlow, and even less support the JAX. Probably not even around the same number, but definitely they are not as well supported as the PyTorch, since a lot of models only support the PyTorch model. So it is still, although it supports all of them, like the PyTorch, TensorFlow, and JAX, they are not equally supported. So let's first consider about the high-level API, which is called pipeline. The high-level API is more convenient, but also lacks of the flexibility. Flexibility, at least comparing to the lower level APIs. But still, they provide a lot of parameters that you can adjust, and a lot of different ways that you can modify and adjust and customize. Here are some of the list, like 80%, because the size of this page. So here are some of the tasks. Most of the tasks have been listed. That maybe I left out like 2 or 3 one, but most of the tasks are here. You can see it consider several popular tasks like the text classification or text generations for natural language process, and for image classification, image segmentation, and object detection for computer vision. Because there are VIT, vision transformer models that is using the transformer as a backend to do the vision tasks like we list here, classification, segmentation, or object detection. So it provides a pipeline for this kind of task. Along with the computer vision and the NLP, it also has a multimodal models, which is like the image captioning or visual question answering. And also, it also has automatic speech recognition. For the multimodal language models, it is still not unified, but some of them you are using like text generation models. You can do chat in text generation models for some certain models. But some of the models like Llama 3.2 Vision, Llama 3.2 Vision, it uses a customized class to load it. It doesn't support the pipeline directly. You have to use a slightly lower level API. So how easy is it to use a pipeline API? It is as easy as import, define, like define a classifier. We do a sentiment analysis. You don't even need to provide the exact explicit of the name of the model. You just give a task. It will choose a default model for you, and you can do the classification. So if you are really in a hurry, you want to build a AI functionality into your app in last minute. You want to has a chat, like an AI chat, like a image captioning functionality or similar things that provided in this text. This is you can do to actually probably the fastest way for you to add the functionality into your code, because just input, define, and run, and you get everything you need. And also for another task like the automatic speech recognitions, there are tons of different choices like whispers or other things. But the easiest way, if you are using the transformer, it is quite easy. Just import it. You probably already have the transformer installed. So you simply run these two lines. It will download the model for you automatically and choose the right one for you. I think it is probably using the Whisper v2. Although v3 exists, but it probably uses the v2. And it can transcribe. By given the audio files, it can transcribe the audios for you in just 3 simple lines. For the model downloading, like using GPU or everything, is done by the transformers automatically. Another pipeline you might want to use is like the VQA, visual questioning and answering. So it is using a repo, a model repo directly. The difference between this one and this one is this one is given a task right here. You can see it, and it doesn't specify which model it wish to use. So the pipeline will choose a default one for you. But in here, we choose a model explicitly here. Because VQA is not yet that mature, so each model perhaps has its strong field and their weakness. fine-tuned for certain tasks. So it might be a good idea if you choose the model right for your task. So here this example choose the model here, and it's still 3 lines. It just you have to choose to explicitly give the model you wish to use, and you can see that it can be used as a path or a repo identifier. So in this case, it is a repo identifier. So it will download the model directly for you from Hugging Face. And the output is VQA, and you give an image and the question, and it will have the answers for you. Still just 3 simple lines. You get your output. So in this case, it is reading an invoice image like this one, and ask what is the invoice number. So it will search from the image to find out the text and to see what number is corresponded to the invoice number. Also, it is probably more popular usage in current days is to load some or try out some modern language models, large language models. For example, here is a simple examples of how to load the Llama 3.2 3B models by using the pipeline API from transformers. In fact, this is an example provided in the Hugging Face repo of Llama 3.2. So as you can see, it is just 3 different lines. Maybe 4, 1, 2, 3, 4, 5. Literally, it's 5 different lines. But 2 of them are import the modules like torch, and of course we have to import the pipeline as well. And to be fair, the torch is only used to specify the torch D type here. It is totally fine if you omit this line and change this one to auto. It can still do the job. One more extra line is we put the model name in another variable. It is totally fine to just in this use case, it's totally fine to move this string to here directly. Other than that, it just has some options like explicitly assign the D type and explicitly assign the device map right here. It is totally fine to omit these two. If you are not caring, if you have a very good hardware and not worry too much about how to control the model is loaded, you just want to use it, you can omit these 2 lines. But you have the choice to have more fine-grained control on how to load the model. And after that, you can simply use the model by using the pipeline. You can load the instruct model. This one is the base model. It has an instruct model, and to run it like a chatbot behavior. Also, pipeline can use large models with Accelerate, which is a library. You can see that we have an emoji, Hugging Face emoji right here. This indicate that the Accelerate library is part of the Hugging Face, is owned by the Hugging Face. So Accelerate library is a Hugging Face product. So we first pip install the Accelerate, then it will be used automatically by the transformer. So you simply set the device map to be auto, it will take the benefit of the accelerate to maybe like a distributed computing things. And also, if you are installing the bits and bytes also, which is a popular quantized library, and it is supported by the transformer. There are other quantized libraries supported by the transformer. We'll see it in a few moments. So if you install them both and you ask it to has auto device map, and for the supported models, you give a model keyword argument to load in 8-bit, then it will load the model in 8-bit. Typically, the model will be stored or published in 32-bit or 16-bit. The 16-bit has different format like float 16 or bfloat 16. Some quantized models are in various different bits, like 8 bits, 4 bits, or even maybe like 5 bits or 3 bits or 6 bits or 7 bits. But this requires specially designed quantized loader libraries. But typically, they are released in like 16-bit or 32 bits. Usually, if you for a language model, if you quantize it to 8-bit, then the performance won't be decreased or degraded that much. It is a quite safe choice, but you can save up to, if you comparing to 16-bit models, by running the models in 16 bits, it saves 50% of memory. By comparing to 62 bits, since it consume only like 25% of the memory, so which is essential if you are running a big model. So in this case, because of the integration of the bits and the bytes, you can use the bits and bytes library quite easily with the transformers pipeline. And it also integrates with the Gradle. So as you can see, this also demonstrates the importance of the ecosystem. If you have a lot of different things that can work together, everything can help every component can help each component together. So the benefit is kind of getting something like exponentially great and powerfulness. So for here, not only the pipeline is easy to use, it is easy to demo. If you have a pipeline, you import the Gradle, you can actually serve the pipeline and launch it, which has a web UI, quite well web UI like here, because we are using a VIT-based image classification model. So after we build the pipeline, and here is what we got. You can upload the image to the web UI, and it will generate a result in just 2 lines. To be fair, we are using the high-level API of the transformers and high-level API of the Gradle. So it sort of have some deceptiveness of the simplicity, because in real life you probably want to have more control. So you probably were going to use a lower level API on one of the things. If you're more focusing on the interface, you probably are going to use the block-based API instead of the interface API of Gradle. So you have more control to the layout and provide more functionalities. But you can still keep the pipeline here. Maybe you can import many different pipelines, like chat models or other things just in each model in one line, and focusing on the UI building. That is probably more like a more practical scenario. But if sometimes it is exactly what you want, you build a model and you construct a pipeline that is compatible in transformers. So when you wish to demo these two lines, it's what you need, exactly what you have to do to provide a simple demo. Just two lines. If you don't have these things, building a web-based UI demo is kind of, imagine you use a Flask directly or using maybe a Fast API, or maybe even you use a more complicated things like a Node.js based web framework. You have to really worry about how to do the things. You probably will have a front-end server and a back-end server, and probably have an AI server. And you have to write the front end. Maybe you cannot find the engineer that has the full stack engineer who familiar with the AI, familiar with the back end, and a back end web server, and familiar with the front end development. So you probably can't even find one guy that do all things. You have to find 3 guys to do that things, and it will take weeks to develop one demo. But right now, if you are only familiar with the AI development, you can develop your own model, train your own model, and everything is done in just one line to provide services here, including the front end part and the back end part. A slightly lower level API is the auto classes. So you can load the model from auto model, like that from pre-trained to load every model. Not every repo is supported by auto model, but a lot of them is. And even if it is not, there are some subclassing of the auto model so that you can use it. The reason that we need an auto model, the auto model is not exactly the pipeline, is the auto model only handles for the model itself. For a model to be actually work, you need some preprocessor and post-processor. This applies to probably every models, like language models or image models. So for example, for language model, we probably need a tokenizer before the model. So here we load the tokenizer using the auto tokenizer from pre-trained. Because they are from the same repo, so they are not exactly for the same repo. One is for cast and the other is for uncast. But if you are using the same repo right here, they will be compatible. However, you can, you probably are going to develop a model that is have special functionalities that is probably not compatible with existing pipeline yet, but you still need some standard preprocessor or standard post-processor. So in this way, you can, like here, like tokenizer, standard tokenizer. If you are using if fine-tuning a new model or develop a new model, probably will start with existing tokenizer. So you use auto tokenizer to load a tokenizer for you, and use an auto model to load your model. Here's an example for loading the Florence 2. We're using the auto model for causal language model. So this class is suitable for most of the like chatbot, like Llama, like GPT-2, or for example, these things are for Florence 2. it can load a lot of models. So I'm loading here. The magic of how, because Forest 2 is a multimodal model, it has the functionality of using the visual input as well as the language input. So it is not a standard language model. But the reason that it works is that it contains the customized, the custom code in the repo. I mean, in the model and in a model repo. So when we load the from pre-train and from the here the auto process from the pre-train, it will load some Python code that is specifically for Forest 2. So this is why we need to put we want to put the trust remote code equal to true here, because we know that it tells that we know it is containing some Python code, and we trust this repo because it is from Microsoft. Some people don't trust Microsoft, but well, it's still official. You are going to use it, right? So it is official product from Microsoft, so you are going to use it. We have to trust the code. Either you don't trust and you don't use the model, or you use it and trust the code. So if we are going to use it, we trust the code. So we put it right here. But the model, as you can see, is not just a static things. It may contain some code. So there are security concerns if you are loading untrusted source of the code. And because Hugging Face, everyone can publish or release their model on Hugging Face. Loading model from Hugging Face from unknown user it will be very risky. As risky as like you are downloading some unknown software and wrong on your computer, and probably even riskier because the only thing between you and blocking the malware or virus is by the Hugging Face transformer software. So if you ignore the warnings or errors from given by the transformer, you are probably defenseless. So just be careful. Only load the models from trusted sources. There are other ways to load the model by explicitly given the class that is the code or class that needed to load the model. So for example, by using the auto, it may have some trick that contains some code to load itself from the model. If you don't want to provide those code in your model, you can provide the code or implementations separately, like here. The llama for conditional generation, by using this customized subclassing from the other models. So this is the example for using Llama 3.2 11B vision. It has a customized code that to load the model. Although this model is still compatible and can be used as a transformers model. The auto model for causal LM or other auto models. The trick of these auto models is they try to find the right loader for you. So for example, in some cases, if you are loading a Llama model, because Llama is already the regular Llama, not the vision Llama. The regular Llama is already supported by the transformers. It will search and use the Llama models class to load the model weight for you. To train the models, the transformer also has a way to let you to train the models. To make it a little bit simplified, you need to control a trainer. So you give some parameters like what the model is, what is the training argument, and what is the data set for training and evaluation, and what kind of metrics you want to kind of monitoring and see. So you control a trainer. Then you do the trainer.train. It will do the training for you. If you want to train it with Keras or PyTorch, there are also some example or standard pipeline or routines to do so. Here is an example to train the model with Keras. You use TensorFlow Auto Model for sequence classification and from train to load the model. And this way, it can run it in a Keras manner to do the training. If you are more familiar with Keras, transformers working well with Keras. The Keras also has its NLP. I think it was called like Keras Vision, Keras NLP, Keras something, but I think it recently renamed to like Keras Hub. I probably should put it in the alternatives or to the Hugging Face things, but I forgot to do that. But right now I remember it, so I just mentioned that Keras also has its own repository. But other than that, Keras work well with transformers, like what you can see right here. And you can do the distributed training with the Hugging Face accelerator as well. It is most I use it more for the training, not for the inference. I mean the Hugging Face accelerator. I use it more for training. Less for I don't think I even use it. I have actually need it for the inference. I haven't used it inference for multiple devices, but I use it for the training. The training, it's kind of like a rapper or a kind of a monkey patch to the original training routine you already have, and make it automatic to be run on the in a distributed manner. So how to use it? First, you import the accelerator and control the accelerator instance right here. And all you have to do is to transform. We are working more in a PyTorch way. I think it only applies to a PyTorch things. So in PyTorch training, we probably will have a training data loader, evaluation data loader, and a model and optimizer. So we use accelerator .prepare to transform the single like a single node trainer into everything into a distributed version. So we give the training loader, evaluation loader, model, and optimizer to the prepare method. It will return a version of the train data loader, evaluation data loader, model, and the optimizer that works in the distributed manner using accelerator. And this is not done yet. You still need to do even more modification. But as you can see, it is not too difficult to do modifications. So in the actual training, instead of just computer the laws and doing the original backward, you have to do a special version of the backward propagation. You are not using the loss backward. You are using the accelerator backward. Then that's it. After you get everything, And also you don't, I mean, even if you are using CUDA, you don't put the batch into a CUDA explicitly. You are letting the accelerator to do the, moving the things into device for you. So, but the backward, you need a special backward version. So you put the accelerator backward on the loads, and you do the optimizer step, LR schedule steps, and all the other things as well. This is just regular thing. The only difference, you need to use the accelerator backward. The other information, you have to do a setup. I mean, we didn't provide the information. As you can see, we didn't provide the information of, okay, how many machines you are going to use, or are you going to use GPU or TPU? We didn't provide the information in the code. The information is provided to the accelerator separately. You need to run on a system-wide or environment-wide configuration for the accelerator. I think it probably has a way to load customized configuration, but I never use it, so I don't know that. Because usually you have built a multi-node distributed machines. You probably are going to use that setting. And every time, I mean, if you have, let's say you have 16 machines, sometimes you want to use only like 8 of them, or maybe using one machine. If that machine have 8 GPUs, you want to use only 4 of them. I probably will run the accelerate config again to change the configuration and run the code. But the accelerate config, after you run it in command line, it will after you run it in a command line, it will run like a interactive user interface, a really primitive one. It just print out several options and ask you to provide which one is like yes or no, or which one is like kind of like a APT things, but it has multi-level of menus you need to config. There are also something less interactively that you can, in command line to do the config in one step, or other more programmatic way to do the configuration. But like I said, you don't have, if you don't have too many like 8 GPU machine, you probably were going to do that once, and probably it's not that familiar with it. So it is probably a good idea to explore all the options and to see what happens. And after you do the configurations, there are a lot of different configurations, like different backend, and some of the experimental options you may want to try. And after you do that, you run your train.py by using accelerate launch train.py command line tools to do the actual training. So for people that is more familiar with notebooks environment, the command line training is probably feel a little bit uncomfortable, or maybe even impossible. For example, you only have access to the Colab things, which doesn't have the command line. And even if you are working with GPU notebooks, it is probably less intuitive to run the code in the terminal in a GPU notebook. So you probably prefer to do this in the notebook. If you are that kind of guy, you can do so, because it also provides the functionality to launch the accelerator in notebook. But I don't think, well, I can think some usage like interactive training and testing the trained function after this sale. Yeah, but it doesn't provide much, especially if you are running a big like a really big training that actually require a lot of computation power and multiple nodes. You probably are going to train it like hours or days or even weeks before you want to actually use it. So that is probably more suitable to run these guys uh, instead of in a notebook. But it supports to train in a notebook. So for example, if you're using the TPU, and the training is probably like and if it supported things like that, you probably can train it in a notebook or maybe even in multiple GPUs. But you are running a training like 10 minutes. There are use case for that, and you can use this notebook style to do the training. So because they are providing this function, definitely some people are this is useful to some people. And to be honest, I have used this before because sometimes because I am a notebook user, so I do feel more comfortable with notebook. So if I want to try some training that does not take like days or weeks to do so, I will use this one to do things, or maybe like 20-minute training or 10-minute training, or maybe in a collab. This one is quite useful. Okay, so another part of the transformers is it has PEFT. PEFT stands for the parameter efficient fine tuning, which may sound a little bit unfamiliar, but you may heard of LoRa, low rank adapter. LoRa is one of the very famous example of the PEFT. There are other like IA3 or ADA LoRa are also considered to be the PEFT, kind of a PEFT. So PEFT is just LoRa and other things like LoRa, not only the owner. So transformer has support to the PEFT, which is also owned by Hugging Face, a product of Hugging Face. And transformer also support agents, either the one-step agent or multi-step agent. So for example, this is just a glance of what it provides, the functionality it provides. It provides a full list of functionality that I'm not going to cover it in this lecture. This is just an example of the code agent. So it do has a code agent to like actually to like, could you give me a title or page of URL in this block? So it will run the code for you. It has a React code agent and like a code agent. And you can add some more tools like download tools and a lot of different tools to make it more. It is an agent, so it will do a lot of things for you, and using the large language model. So the transformer itself can already do a lot of different things already. Also, it supports a lot of quantization methods. Here's a list of them, like AQM, AWQ, or maybe like GGUF, the GPTQ. These are probably the most popular quantized method you can see. Also, the bits and cents. The supporting level is various on different platforms. For CUDA GPU, all these methods, quantized methods is supported, but they support different kind of quantization bits. Like AQALM support like 1 or 2 bits, which is kind of extreme. And AWQ support only 4 bits, which is a popular 4 bits quantization method. And BitBytes support 4 and 8 bits. And also it can support fine-tuning from PEFT library that we just see before. It can, one of the benefits of your BitByte, it can do the quantization on the fly. So you can load the model and do the quantization. You don't need to extra steps to do the pre-quantized model. And also GGUF can support various bit lengths, like and the GPTQ as well. It can support different like 1, like 4, 3, like Q3, Q5 things. However, the working with transformer support is partial, meaning not every model architecture is supported. In here, the partial means not every model architecture is supported. It supports a wide range of popular model architecture, but not everyone. Bits and bytes seem to be more compatible and work really nice with transformers, but it only works better with 8 bits, or it only supports 4 and 8 bits. And there are transformers example, like a gallery that we see in like for Matplotlib or in scikit-learn or in OpenCV. There are also something similar to the gallery. Here is the gallery, because it is more like a coding library, not the visualization library. So you don't see many images or picture, but still it's kind of like a gallery. You can see a lot of different use cases that you use with all these notebooks. It is a really long list. You can find a lot of useful examples. Even if you are using it with, probably you are not familiar with using it with TensorFlow, it provides a lot of TensorFlow examples that you can use with transformers. So maybe in some situation you need to use TensorFlow, but you want to use transformer model, and you're not sure. So your most familiar model is not supported by TensorFlow. You want to use a TensorFlow supported model instead. So you can try to see these libraries to find, these notebooks to find the examples similar to your task, like fine-tune things or using the different model. Okay, so here are all these models, and I didn't put the optimum library in this slides, but optimum is one of the Hugging Face library that helps you to run the transformer faster on different hardware and platform. Say for the Intel, NVIDIA, or AMD platform, to make it more efficiency. So here is example for the optimum. So you can see that on the Intel Neural compressor, or maybe run it with UNX runtime. So here are some examples that you can follow. There are also community notebooks, which are also very useful. Although they are community things, they provide a more, they are still very useful. A lot of things have reference to from the community notebooks. For some functionality that are not provided example. The example are not provided in the official notebook gallery. So they are, although the list seems to be shorter, they are useful. So you can find the things. A lot of time, the notebooks that I find is in the community ones, and also the similar things works for diffusers too. As I mentioned before, we are not going to introduce detail about the diffusers, but diffusers also have this kind of thing and has community notebooks and the official notebooks. Both of them are very useful. Okay, so diffuser is also non-library, sort of similar to the transformer. Also the names looks a little bit kind of equivalent, like there are some source, some ERS. It is mostly working for the diffusion models for image generation. It is apparently that it is an equivalent of the transformers in the image generation part. Although I think transformers is a bit more successful, significantly more popular than the diffusers, but diffuser is still quite popular and useful to us, and it shares a lot of philosophy, design philosophy, and the functionality of the transformers. And it also provides a quite long list of supported models, not only to the diffusion model, but also to some diffusion-related models or diffusion-inspired models as well. Like I think it has Muse, M-U-S-E, and it has a version called Amuse, which is not exactly the diffusion model, but it also supports this in the diffusers. But I think the list of diffusion models is significantly shorter or not completed comparing to the transformers. But still, it is quite good library and quite useful. Okay, another major product of the Hugging Face is the Hugging Face Hub, which contains different parts like repository, code repository, and the dataset is still like a repository, but it's for dataset. This one is for code. You can consider this is like a GitHub or GitLab things, but hosted by Hugging Face and integrate with other services. And the other is dataset. Both of them are kind of like Git, but dataset and the models are more like a large use Git LFS because they provide large files. So all of these are kind of like Git, but for code, for dataset, for models. And also it has a space. The space, okay, I kind of forget that to mention in alternative that the GitHub also has similar things like space, which I will talk about later. So space is things that you can run the code and run the demo using Hugging Face hardware. So for example, I will show you one example in Hugging Face that is the Llama 3.1 AB. Right here, you can see it has a model card to see what the model it is and the model files and the version you can see right here. And it also has a community section that you can communicate with other users and maybe the author. When you see the file and the version part, it looks like the thing that you will see on GitHub because it has a different branch and different files. But because the model usually has a large file size, so you will definitely see the most important part is in the LFS things. You can actually download everything by using git command. But for models, it will probably more useful to more frequently to let the Hugging Face library, the transformers or Hugging Face library to do the download for you. Because when you use the git to download, it will download everything like a history, the git history. So it will take too long time. So it will be more convenient to let the Hugging Face library to do the work for you, and the models is going to be downloaded in your home directory, the cache subfolder, and in Hugging Face subfolder. Also, you can see that a lot of files is provided in safe tensor format. Safe tensor format is developed by Hugging Face, which is a new simple format. It is really simple because you can see that I actually several times do the code demonstration, and one of the part is to load the safe tensor and writing like GPT models by using NumPy. But because I want to use, I have to load the weight of the GPT, so I choose safe tensor format to load because safe tensor is the most easy one to parse. So I write maybe in 10 lines or maybe in 20 lines. I don't forget, I don't remember, but it is very short code and easy to understand format that you can write parser really easily. And it can store the tensor safely compared to the Pico. Because Pico is an unsafe format, it requires to load code like what we mentioned in PyTorch lecture. PyTorch usually save their weight in a Pico format, but Pico is not safe. So there's a way to load Pico safely, like save Pico module or so. But the benefit of Pico is it is more flexible. So the code loading is kind of required because it supports customized your customer code or customer class. So it definitely has to run something to load these things. Otherwise, you have to do things in a more code it in a more different way. So the PyTorch support a way to save it in a PyTorch script things, so that you don't need to run any code when loading. You have to run the code before. But anyway, the safe tensor is another format that is more generalized. Not only for PyTorch, it can support anything. And the storing tensor in a more simple and safe way. It only storing the weight, and that's all. It doesn't storing the logic. It only gives you the name of. It's kind of like a dictionary. You have a key value things. That's all. Because it has a key value things, so you know the layer name and the layer, what the layer it is, so you can load them in your model. But the model itself is another. The code you have to run separately, so it is more safe. And also it is fast because the library it support like zero copy things, so it will be very efficient, memory wise and fast. Other than the transformer library, the Hugging Face also support a thing called the serverless inference API, so that not only you can run the model inference, but also you can run it on Hugging Face software instead of on your own machine. It has some limitation. Not every model support it, but a lot of models support it. So like if you see the Llama 3.18b, you will see it has an inference API right here. On the right hand side, mostly on the right hand side, and you can actually run it. So you can run the inference API to the Llama 3.18b right here, and you can see the code to how to use it. So here is the code. It has to do something like request to, so it can fire a API request and get a result. So you don't have to host the things on your machine. A lot of API coding are free with some limitation, but you can do a very quick prototyping and try different model with your logic or with your things. And it supports OpenAI like API as well. You can use curves as well, using a command line tools to do the whole AI things without hosting it on your own machine. It also provides a really easy interface called the inference client. So you don't need to write code like this one explicitly. You can just run the like a client, inference client here. Let me show you an example of my own space here, right here. So here is a Hugging Face space I'm using. This is a chatbot, simple chatbot. It has some additional parameter that I can set, but I'm not going to use it. Like a system message or like maximum tokens, things like that. Maybe I can use it more tokens, like 1000 and the different temperature. Okay, so maybe I can say recall that I'm using a CPU machine. I'm not using a GPU machine, so it is actually a free machine. We will mention it later. It is a free machine. In this is not a zero GPU. This is just a CPU machine. It will run at the cost of myself. When you run a zero GPU is also free. But if it's going to, the quota is used by every user, not the owner. However, if you're running a space using some GPU hardware, the cost is on the author, on the hoster, like myself. If I'm using this space, I will pay the cost. But just because I'm using the CPU instance, the smallest one, it doesn't have any cost, it is free. But of course, because it is free, the hardware is not very powerful. By using the inference client, because the running is on another machine in Hugging Face, so even though my hardware is really limited, it can still run the inference pretty fast, because the actual inference is not run on this machine. It's kind of like an API service from Hugging Face. Okay, let me list the top 10 highest mountain. So you can see that it's really fast, almost instantly replied. So it actually lists the top 10 highest mountain in the world and how high they are. Okay, so I can actually see the code. No, not this one. This. Okay, the files. I can do the setting to make it into change the hardware to be 0 GPU. But I don't need to do the GPU because it is not using any GPU, and I can actually do things like let me go back to the app itself. I can restart space or enable dev mode, which I will slightly mention. It's kind of like a GitHub service to run a Visual Studio Code, web-based Visual Studio Code, or you can using SSH into it. And also I can get a command out of how to run these things in a Docker. It takes a while, but usually you will just see a command how to run this space exactly in the Docker. So if you see a demo on Hugging Face and you see really interesting, you want to host it by yourself, the quickest way is to check this one and see how to run it in Docker. Let me see the files. So here is the simple files here. It doesn't have much. As you can see that the code is quite short. This one is a Gradle code using chat interface to add some controls right here. Here is a simple response method function to handle the chat interactions. It's really simple. Just run through the message and yield the response. And the chat AI itself, I'm using Mistral 7B instruct. This is kind of a huge model that I will have trouble to run on my machine because it is a 45B parameter model. 8 times 7 is 56, but because it is a mixture of experts, it will slightly less than 56. In fact, it lists as a 45B parameter model. It has 45 billion parameters of this model. So it's a quite large model. If I want to run it in 16 bits, it will require maybe it is run in quantized version. I'm not sure, but even if I run it in 4 bits, it would still require 22 gigabytes memory. But I run it without any issue and run it really fast on my free machine here. Because it is running in API. So it's quite interesting service. We'll see some alternative of this serverless inference API. So I'm using a mixture here. And if you see a model, you can also, it's a good thing, you can also see the other fine-tuned model or related models and explore other models and explore the models that, the spaces using these models as well. All these functions are very quite convenient to use. When you want to create your own space, you have several different choices. You can choose from using a Streamlit UI, or using a Gradle, or using Docker, or using static. I'm mostly using Gradle. I haven't used Docker yet. The Docker provides something like the Jupyter Notebook instance. I am quite interested in what it is, but I haven't tried it yet. I'm using most of the time I'm using Gradle to to serve a demo. It has some template like blank one. Blank one is work quite well because I usually already have a code, and it has some template like a chatbot, which I showed you before, and text to image, and the leaderboard, which is quite interesting instance because you can see a lot of leaderboard on the Gradle. I mean on the Hugging Face space. The one that I show you is using a free hardware CPU basic. It has 2 free virtual CPU and 16 gigabytes free. I mean 16 gigabytes memory, and it is free. If you are turn on the dev mode, you will see that you have some choice to connect to the space instead of like modifying. I mean, because it is kind of like a Git things, kind of like GitHub things, you can actually push your code to this GitHub, I mean Hugging Face repo, and it will automatically update your demo. But like GitHub, you can edit it online. Like here, I use edit here. Say maybe I can change the system prompt right here. You are a friendly chatbot. You are angry chatbot. Maybe I can do that, and I can commit this change to here. And when I go to the app, you will see it is building. I can still using it. Because it is very small one. It's already building, but it restart. So currently it is, because it is restarting, we are using an old version. So it is kind of still like a happy, friendly chatbot yet. But after the incident is getting restarted, I will get an angry one. Okay, so it is restarted. So you can see that it is becoming an angry chatbot. And I can say, hi, are you? And to test, I haven't tested it before. I'm not sure. I don't say it is quite unfriendly. It may be angry and sad, but it is not. But anyway, you can change it in the parameter. Additional import it right here without modifying code. I'm just demonstrating that how it works. It is just hosting the things based on a Git repo. So everything is stored on a Git repo. But if you are you're working with the dev mode, the things get different. You can have a more modern user interface to do the development, like VS Code web, or you can connect the VS Code from your local machine to the Hugging Face, and you can use SSH as well to do whatever things you want via the command line or using the SSH, like copy files from your local machine to the remote one. You can do that. But the machine is temporary, so you have to sort of like commit everything to the Git before it to be permanent. Otherwise, if the machine restarted, every storage is going to be cleared. It will pull everything from the Git repo that you committed, but not the temporary files that you are like putting in your SSH machine. So here is a simple example of the web VS Code UI that you can see right here. I didn't want to show it lively because it will take a while to switch to the dev mode. So I'm just showing you a screenshot of what the web dev interface it is. I usually use it in dark mode, but because I'm putting it on slides, so I'm deliberately changing it to light mode and show you the picture. Okay, so for the space hardware, it is free to use CPU. Starting with 0 per hour, but other than that, most of the things are going to cost you something. You can upgrade your CPU or using like T4 or L4. The pricing is a bit higher than what you can get, even comparing to the like a GCP or AWS cloud. GCP is a little bit more expensive than AWS. But here it is I think it is even cost even higher. But the thing is, it is not for training. You can turn on, turn off anytime you want. So another choice, to pay is to have persistent storage. Like we said, it kind of have storage, but it's basically just everything you are having on the repo. So you have pull the things from the repo. So if the you want to really have some like a database or other things like storage, you need to pay to not. I think it's kind of fair. Like $5 for like 20 giga. If you have a database that large, like 20 giga or maybe like 150 gigabytes for $25, it's a fair price to pay. Otherwise, you have to connect to your own database. You can do that as well. But well, this is a listing of the price. I haven't used any of these yet. But one of the interesting things is the little GPU space. So here is a thing to what the little GPU is. Actually, you are using a free CPU machine, but you will put everything that work on GPU. It will automatically assign a free a GPU node to do your heavy duty works for you. Currently, it only support the Gradle, and you have to do some modification to the code right here. So if you want to do a diffuser, do the diffusion pipeline, first you need to import space, install the space package before you use it. But in the Hugging Face space, it has this package already. And for the function that need to use the GPU, you can use a decorator space.gpu to wrap the function. So for here, we have a Gradle, and the Gradle call this function. When you click a button or things, it will call this function. And this function is wrapped by this decorator. So in fact, this decorator is not running. This function will not be run on your machine. It will run like a remote functioning, remote procedural call, kind of like a remote procedural call. So that makes some issues, because when you return something from the generated function, this function, it will come from remote machine. So you will have to do some serialization. So if this serialization is not working, then this serialization is, if the object you are trying to return cannot be serialized, you will have some issues. So it is not 100% compatible, but if you play nice with it, it will work. And another thing is that you can see that we are actually loading the diffusion pipeline here and pipe it to CUDA. If we are running this, the diffusion pipeline in a remote machine, what does this mean? This will put it in your CUDA. It will put this in your CUDA device, but you don't even have a CUDA device. right? If we are actually running a CPU, and we don't even have a space GPU wrap around it. If these two lines is put into here, inside this function, it makes a lot of sense. But how can it done outside this function? The thing is, the space does a lot of dirty works for you. It will patch the diffusers and the transformers, or maybe in the PyTorch, mostly in PyTorch. So even if you load these things from, pipe it to the CUDA, it will actually not do the things that you are expected to do on your local machine. It will do something like, okay, recognize, okay, you are using this model and put it in CUDA. And the actual work will run when you go into this space GPU wrapped function. So that's why even if you don't have CUDA and you run these two code, you won't get anything error message like there's no CUDA device available, things like here. I have actually tried these things on other than the Gradio functions. Like when I run the dev mode, I wrap a function and see. So you can actually run the on any function. And like in the dev mode, I have run a web version of Visual Studio Code. I wrap a function in a space.gpu. It can actually get the torch to recognize I simply do the torch.CUDA or something to check the available GPU devices. If I put it outside without these spaces, it definitely has nothing. Get nothing. It doesn't have any CUDA devices. However, if I put the whole things inside a function that wrapped by this decorator, it will print out, says, okay, you have certain number of GPUs. So it works on other than the Gradio, but I'm not sure how much it will charge me. I am guessing that after the function has returned, it won't charge me. It's not actually charging me for the money, but there's a limit of a rate limit, like quota limit, for how much GPUs you can use with a zero GPU. So because I'm not using when I use it in a Visual Studio Code, I'm not using it in a proper way, so it may charge me indefinitely. Probably, I'm not sure. It may cost a lot of quota from my GPU usage. It potentially, but I don't think so. I don't have much. Right now, I don't think of any usage of using this one and using their GPU yet. Instead, except for the regular use like hosting a demo things. So that probably won't be an issue, but it is possible to use this space.gpu on your own function and running, perhaps potentially running the training, but I'm not entirely sure. Okay, so this is the GPU space. You can set the duration of this. Because it is quota or limited basis, so it will count a quota of the user's quota for a user. So, but before it actually run the prompt, it doesn't know how many quota is going to be used. So we're setting an upper bound of the duration. So if your quota is less, in this example, if your quota is less than 120, it will send you an error message. So you run out of quota. Wait a while to cool down before you can use this function. So it has a duration limit set for this GPU use function. There are a lot of zero GPU spaces you can find on maybe like if you go to no okay, sorry. So okay, the GPU spaces. Okay, so for this one, I just pick one of them. If I'm running this, since it is going to use like a dog running, I mean dancing in the rain. So if I run it, it will use my it will going to use my quota of using GPU. So you can see it is generating the image step by step. You will see a dog running and appearing, and you can see it is using A100 GPU, and also a quite interesting thing is you can see which real space is getting popular. Like, okay, this is a fast swap. It seems to be a virtual try-on. So it has a virtual try-on and like fast swap, kind of new things. I haven't heard about, but it seems to be trending somewhere and kind of interesting. So you can use this functionality to explore a lot of new models in the market. So there are a lot of different GPU, real GPU things. Of course, Flux is getting trending for a while already. And what is these images? Let me try these images. I don't know what it is yet. Does it has any example? Okay, let me try this example to see what happens. So it appears to be another image generating model. Okay, cool. Also, we have different, and all this is on my quota. And you can see that there's only one instance running on here. And the most popular one is currently have 4 or 3. Okay, this one is the most popular one. And first to try on, let me try this one. Kind of interesting here. So we have some examples. Try this guy. Okay, let me try this. Quite interesting to. Where should I do? So. Okay. Where should I put submit? I'll try on here. Okay. It will take like 30 seconds. It suggests that it will take like 30 seconds, so you can see that it will run in 30 seconds. Usually, because it is going to load the model, you can imagine if the model is not already loaded, it will have to load the model. So it will take some more time than the local, if you host it on a real machine. But still, it's quite useful and it's free. It's free to use. It's quite interesting. Let me try another one for like this one. Because it has a illustration on it. Let's do it. Again, this one is the UI is crafted by the Gradio. So this is a typical Gradio behavior. So we can identify this as Gradio. Okay, so that's seems to be work quite nicely. Another interesting is the leaderboard. It contains a lot of different leaderboards. I'm not going to do much details because we still have the Gradio to need to cover and other things. So it has a lot of space for, like, you want to check which language model is the best one. You can check the leaderboards. And also Another library which we use it a lot, which called the TIMM, TIMM. It is a collection and a library for SOTA computer vision models, similar to the MMLabs that were OpenMLabs that we're going to talk about. But I cannot list it into a competitor or alternative to the Hugging Face because it is already acquired by the Hugging Face. Here is the post of the author who start to officially join the Hugging Face. So the team is actually now part of the Hugging Face. Okay, another interesting is the Gradio. So here is a small animation of Gradio. Because of time, I probably won't get details about Gradio, but it is sort of similar to the Dash Plotly we mentioned before. It provides a simple way to write the code in Python to build a website. So I probably will give a more dedicated time for the Gradio in the future. So I'll skip the Gradio here. But it is quite nice things. We'll talk about in the future. But the more interesting topic I wish to talk about is the alternative to the Hugging Face, because Hugging Face is getting bigger and huger, and probably will dominate whatever areas it is in. This is my prediction. It is already a very. Arguably, it already dominated the field. But there are still some alternatives that you can comparing with, and maybe to see why Hugging Face is successful, why not others. One of the things that's similar to the Hugging Face hub, model hub, like the hub is starting with a model hub that hosting a lot of different models, and then a lot of code and the space and data sets, things like that. So there are a lot of different attempts to have a repository of models and the data sets. For data sets, it's like Kaggle. Kaggle still hosting a lot of different data sets, but I think the Hugging Face, because the way Hugging Face works, it will become more organized, and which will have more because it is a ecosystem thing. It works with models and everything like Gradio things together. So I believe it will become dominant in this area. But you can see that for a model, there are different attempts to do similar things. Like the OpenVINO, the Intel's OpenVINO, it also has a garden things, a model zoo things. So this one is for model garden from the TensorFlow. It has a NLP for a research model and a lot of models. It not only provides the model from Google, as well as some other open source models. But the thing is the Hugging Face repo is more popular. And this one is the model zoo from PyTorch. It's quite nice, works quite nicely with PyTorch, and I still use it a lot for a lot of different models quite well as like a visual model, a segmentation model, and because PyTorch is getting popular, I really use these models as well. But I think this is not as doesn't work like a community like the Hugging Face that people can, because in Hugging Face it's more like a GitHub things for models. I think Model Zoo is not that like this one, but still I think Model Zoo has PyTorch has its place. Kaggle is also a competitor of Hugging Face, and it is more like a more hosting computation things is its primary area. but it also provides like datasets, models, notebooks, and all other things. Another model repository need to mention is Safety AI. It is mostly for the diffusion, fine-tuning diffusion model. It works in a sort of in a different direction, but like Hugging Face, it is hosting a lot of different models, but most of them are fine-tuned models from like diffusion, stable diffusion family, or maybe flux models, since or other open models like fine-tuned model, or like LoRa or fine-tuned models. But the similar things, it has a community. It has a huge, very healthy community-based things. Unlike the PyTorch or TensorFlow approach, although they are trying to do so, but I don't think they work that well. But the Safety AI and the Hugging Face are more community oriented, I will say that, or maybe inclined to the develop a very like community for popular general public. Also, there is OpenML. OpenML is not community based, but it's more like curated things, like PyTorch model Zoom. But it is very comprehensive and complete. Contains a lot of SOTA models for vision task, and it is open source, like the name suggests. Unlike OpenAI things, you can see that it has some sub-project like detection for detecting object detection things, including tools, bugs, and the benchmarks. Although we use it more like a model things and load all these models in a uniform way. So it's kind of like transformer and diffuser, but it has the detection and the segmentation things, deploy things and other things, pause things. Mostly I use detection, segmentation, and pause. I haven't really noticed about the magic. But it is using for the generative AI, so I probably can choose it, but I haven't chosen it yet. I haven't tried it yet, so maybe in the future I will try it. But I use detection, segmentation, and pause a lot to quickly, and they depend on the engine and maybe deploy it. But they provide a lot of different models, kind of similar to the transformers, and so you can try them in a very quick way. So for example, you want to try object detection models and want to fine tune it to your task or things like that. You probably can simply use the ML detection framework to load a model and fine tune it and do a prediction. And you can try different architecture and pre-train weight in a really quick way, instead of like surfing from GitHub to finding different repos and every new model you have to write a new code. It helps you to use the same code to fine tune a lot of different models really quickly. Also, we want to discuss some alternative to the spaces. Like we say, when I say space, I kind of include all the demos and the development environment, like the web-based Visual Studio Code or like SSH space, kind of like a virtual machine, not only for demo but also for development. So there are some alternatives to the spaces. The first one is Binder. It has quite a history already, but I think it is less famous. The similar things between the Binder and the space is it's actually the similar things that can deploy a GitHub repo a Git repo to a virtual machine, and the virtual machine it provides a web URL, and when you connect to this URL, it will when you connect to a web URL, it will. I mean, when you set a GitHub repo or things like a Git branch or repo or tag, and when you give a notebook or like a file, it will kind of build the virtual machine for you. And let me run one of my, I think this might work. Okay, no, that's okay. I haven't. Okay, maybe later in the afternoon. Recently I changed my domain name provider, so that doesn't work right now. But anyway, I provide several. But when you link to a URL, it will create the virtual machine for you, kind of like the Hugging Face space, and can serve as a demo. It worked particularly well with notebook, but it also worked with something maybe like the Party Dash or other. I'm not sure it worked with Gradio, but in theory it can. I haven't tried it yet, but they are similar, but in a different direction. So that's the similar things, and it is free. It is sort of free for you, kind of like a Hugging Face space for demo. There are a few alternatives. I think originally the NV viewer originally only can view the notebook, but it maybe at some time point, maybe right now, it provides the functionality to host a notebook. So this is a similar thing to the Hugging Face, but it is kind of still like a little bit old style that works for the notebook users, not for the like AI users. But still, it is useful, and you can use that. And another thing is Colab. Colab is probably you are familiar with Colab, so you can see that Colab is primarily focusing on a developed environment. The similar things is their goal is to provide free GPU, kind of like Kaggle notebook here. They provide free GPU for the study, mostly for the people like students, to learn the new things. So they have some priorities to provide free GPU. So in the Colab, if you use more, you will get more priority to use new things. If you are using a free tier of Colab, of course, if you are using the paid version, you are paying it. You can do whatever you want. So if you are using a free version, free account for Colab, it is from the term of service, user term of service, that it cannot use the things like SSH into it. But if you are a paid user, because you are paying the computation time, so this is your machine. When you rent it, you can do whatever you want, like SSH into it. But the new user term of usage, you cannot like SSH into it or use another web user interface as the primary interface. So for example, it is possible you run like a web version of Visual Studio Code inside the Colab, and you use this to connect to your Colab virtual machine, your instance, virtual machine instance. It is possible to do that, but it is prohibited by the user term of user usage. So you should not use the term of service. so you should not use it in that way. However, if you are using the paid version, you are a paid account, it is free to do so. It is not. I don't think it is the Visual Studio Code that the Colab is trying to stop people to use that, to abusing the service. It is more like people might try to host the to use the free GPU resource to run like a diffusion, stable diffusion, like WebGUI diffusion models, or like similar thing, to provide some service, as instead of learning to code or running API things. So that is why they prevent the user to do that. But still, if you are running a simple Gradio example for research, for like study, I think that is totally fine, and people can do that. So you can also, so kind of like a Hugging Face space, you can run a lot of people do that, to run and try some new models, and run a Gradio simple demo on it. The Kaggle provides similar GPU usage. I think it provides several. The quota is renewed every week, and it provides decent GPU hours for like A100 machine. It also has TPU, as like the Colab. It has free TPU, like Colab has free TPU. But the TPU on Colab is too old. It is TPU v2. I use TPU v2 and v3 a lot, but right now they are obsolete because the newer version of the PyTorch support is based on the XLA library. It does not support the v2 and the v3 well anymore. It will support only v4 and maybe v5, but not. But Colab provides v2, but and it's kind of cheap, but I don't think it is really useful because no hardware is supported on the latest software is not supported on this older hardware. The Kaggle provides a newer TPU like v3, but v3 is better than v2, but still it is kind of old. But the free GPU it provided is still quite useful. And well, if you combine the free GPU usage and I think it provides free A100 GPU. It provides free 100 GPU. So it is quite good to use it on Kaggle. It is another alternative, kind of like a Colab. Less like Hugging Face, but still they are similar to each other. Okay. Before I went to that, let me mention the GitHub. The GitHub has a GitHub Dev or GitHub Space. It provides a user interface like a web version of Visual Studio Code, and if you use the because Visual Studio provide a terminal, so you can use a terminal as well. So you actually get a free CPU machine. It has some quota limit, like the network or like the hours. And if you are having a professional account, a pro account or some paid account, or maybe like unpaid but a free account, but like an educational account, you have more quotas. But okay, that can be considered similar to the Hugging Face Space Dev version. So, and that's also free. And I didn't aware of any GPU options, but it was quite similar to the Hugging Face dev, Hugging Face space dev, the GitHub things work quite well, and it is free. This one is a company called MODA model. You can click through the slides to the website. Let me do it because the image does not load. So it is called the model. I haven't heard it before. This is when I prepare this slide, I doing some research to find more alternative. I found this one. It also provides some free GPU usage. Not much. It provides $30 each month for free credit. But it's reasonable, but a little bit toward expensive side for GPU tasks. So $30 for $30, you can use like say, let's just say like L4. You can probably use like, I mean, you still has to pay for CPU for not only for GPU. So you probably will pay. I don't know how it works, but if I'm considering like this one, you probably will have like 30 hours each month for GPU hours. So suppose you work on GPU for 4 hours a day, you can use like 7 days. Sort of, I believe Kaggle provide like 20 hours of GPU time. So I would say this is a little bit toward the not enough side, but they are providing it for free. So yeah, that's a good thing. That's a really good thing to use resource that you can consider. At least you can consider about it. Of course, they are doing this for promotion, but they don't have to do that. So I appreciate their offering. Another thing is like the serverless inference in the what I do in the chatbot space things, and it is free. So there are a lot of serverless inference APIs. If you want to pay, if you have to pay something, there are a lot of, and some of them have some free quotas. But I'm only use some of. I'm only going to only list some of them because a lot of API have some like a free tier try out, like TTS, text to speech things, or a lot of things has like 11 left has certain speech based API that has some free tier usage limit. So this is by no means a complete list, but I list a few things I think is interesting. The one is the Cloudflare Workers AI. The Cloudflare is mostly for like content develop CDN, content deliver networks, and for other like firewalls and similar lots of network things. But it also has an interesting feature called the Works AI. It is a paid service, but it has a certain free limit. So if you wish to use the text generation, you can generate up to 10,000 tokens. Not much actually, but it's something. And it has speech to text and embedding and image. And I think it is toward the not enough side. It is the limit is quite strict, but I list it because it is. I just recently learned that Cloudflare has this kind of, and it is really interesting that Cloudflare provide a lot of different variety of different functionalities. So at least it's just because it is kind of interesting. If you really look at a lot of API or serverless things provide kind of providing things like a lot of AI API provide some free quota. And for the Cloudflare, it actually provides a quite decent list of models it can be used on the API. So here's just a part of the models that is listed in their category. Like even like Flux or DeepSeek Coder, which is quite good. That I may think I probably will try it a little bit. But I have too many. I have other choices, but so like Hugging Face, I already paid for it, so I have more quotas. So I probably will not try it. I haven't tried it yet, but it seems like an interesting choice. Another thing I want to mention is the Gemini API for Google. Like what I said, the Google Garden is also Google Colab is also considered as an alternative to the Hugging Face. Google Model Garden is not that successful, and Colab is quite successful, but they're still like aiming on a slightly different angle than the Hugging Face space. Here is another thing like the API, free API things. Google has a Vertex like GCP, Google Cloud Platform, to provide full functionality and the paid version of all the things. But aside from the GCP part, it also provides AI API for free and paid accounts. So for the free Gemini API, it actually has a quite general offers that you can use for free. It has a rate limit, but the rate limit is quite high. So if you are not using it, you are not abusing it, you are going to have a quite decent amount of quota that you can use. Sort of like the Hugging Face API, but of course it only serves the Google models and maybe some open source model, but mostly the Google models like Gemini or Gemma model. And although the choice is a little bit limited, but Gemini models are quite, initially it's not that good, but it is catching up, and one of the best models available in commercial world like Gemini and in open source world like the Gemma. It provides quite user-friendly, developer-friendly web page that you can see how to write the code for it. So for example, at least for the Gemini 1.5 Flash model, the rate limit is quite high. No, the image is not loaded quite for. Okay. Okay. So here is a free of charge rate limit. You can request 15 per minute and 1 million tokens per minute. So 1 million tokens per minute is like 1 million token per minute is like no limit at all. If you are using, if you are not trying to do serving the things on a web page to let many users to use it, and the 15 requests per minute is, I think, it's very fair. It's kind of fair. So each request take like 4 seconds, and for 1,500, you are going to use more than 50 requests per hours. So even if you continues to like sending a request for every 30 seconds, you are still in the free quota. And the inputting pricing is free of charge, outputting is free of charge, and the context catching is free of charge, and you can save a lot of the token per minute things. Although 1 million token is really I think if you are trying, if you're not trying to use the large you have a huge prompt, and I think you are not going to pass the limit, or maybe you are not using a fission things, because you are using fission things, it's going to cost 1,000 tokens per image, things like that. Then you will get the limit quite fast. So if you have a large system prompt, or you are using audio or image, you probably will want to catch things. And the best thing is it has free to run the tuning. I haven't tried it yet, but most of the time I tried it, it's just for the pre-trained model, pre-trained weight. But as it mentioned, the tuning is free. You can tune your model for free, and the tuning service is free for charge. The input output price is as the same over a tune model for other model, which is free because we are using it free right here. So you can actually customize your models to fine tune your model, fine tune your Gemma model, and all of them you can use it as free. Unfortunately, you are not going to use the grounding with Google search, which we will see later. But you can use code, using the running a code interpreter. That is, you will see later. That every other thing is free, except for the grounding with Google search. But your data, because everything is so free, so your data is going to use to improve their, it says our, because they are saying, Google is saying, the data, they are providing this free because they are using your data. So that would need to be, if this is something you need to worry about, you probably are not going to use the cloud AI services because there are no guarantee they are not using your data. But especially for these free of charge services, they are saying clearly they are going to use your data to improve their products. So if you are trying to send something sensitive, like when you try to tuning your models, you probably will have some data. They are free to use your dataset to improve their product, because this is yes right here. Recently, it provides the OpenAI compatibility because they realized that the OpenAI API is dominant. So they are going to provide a version of OpenAI API, compatible API for the Gemini API. So you can use OpenAI module in Python to actually just change the base URL to the Google and use their API key, kind of like the VLM or maybe LM Studio, since because OpenAI API is sort of dominated, or at least is hugely popular. So a lot of libraries or services are providing OpenAI API compatibility. Like the Hugging Face API also provide the OpenAI compatibility. So you can change this URL to the Hugging Face instead of the original OpenAI endpoint, and everything else, keep everything else the same. Of course, you need to change the model name, and the model behavior will be different. But for a code, for the coding API, you can use exactly the same thing. Also, there are Gemini models listed here. They are quite actually good. Some of the benefits of them is the 1.5 Flash model is fast. It has a AB model, which is super fast, and the Pro model performance comparable to ChatGPT in a lot of benchmark. Originally, when the Gemini was originally released, people complained and criticized that it is far behind the ChatGPT. It's not as good as ChatGPT, but right now I think a lot of models has been catching up. So although the variety of the provided model is not that huge, but in every user case, it still has a quite good models already. And one of the benefits is it provides a huge, comparing to open source model, it provides a million tokens window, context of window context window. I mean, it has a very huge context window. And other benefits is that one of the things is it can have image and text input. It can support document reading, so it can read document like PDF, Python, code, HTML, RTF, Markdown. Especially it can read the PDF. That's one of the good things. And the maximum supported document is 3,600, which is huge. Also, it supports like a video input. You can upload to approximately like an hour of video data to your language model. And so is audio files as well. One of the strong field of Google is Google search, so it can grounding with Google search. However, you have to pay for it because it is only for a paid user. But that's one of the options. And it has a functionality of code execution. It's kind of a tool using, but the code is running on the server side. So when you use a tool using API, you are calling the language model, and it will ask you to run. It give you some like JSON parameters. A JSON format consists of the function it requires call and the parameters, and then you call the function on your local machine and provide the output result back to the language model, and it will continuously run. That's usually tool using paradigm. But for a code execution, the difference is that they will have a small virtual machine on the remote, on the cloud side, so they will run it on Google for you. Of course, it doesn't have you will rely on the module already installed on that virtual machine. Instead of, you can freely install any Python module on your, or maybe you can use like Rust or like use Go or other language you like. But this is very convenient because it can run in one run, and it is free, and it's free to use. Besides the text generation, the text generation thing, it can take video, audio, image input, but mostly it only provides the text output. Maybe structured text output like JSON, but it's still text. However, Google has an image generation model which is called Imagine, and it is currently at the third generation called Imagine 3. It works quite well in a lot of academic metrics, research metrics. It's arguable it does not work a lot well comparing to the more commercial image generation models in real world, but it still can generate quite good qualities in practice. So there is Imagine 3 API provided in the AI studio of Google, and it can take prompt in many different languages like Chinese, English, Japanese, Korean, Spanish, things. But currently it is still in beta testing, so it is not. I don't think I'm not sure it is generally available, but they are trying this thing, and maybe it will become available to the general public in very short time. But at least they are planning to do so. So this is another benefit of using it. So not only I mentioned this is because one of the drawback of the Google Studio API, Google AI API here, Gemini AI API, comparing to a Hugging Face, is more limited to a selection of the models. But if you're considering they are providing Imagine, so at least in every different field of people are interested, they are providing something. So that is addressing the variety of models. Okay, so that's all for today's lecture. So we'll see you next week. Probably we're going to talk about Gradio and other similar things.